study, we learned that if we have two particles move towards each other, then there must be a collision of the particle. And because of that, we have the before collision and we have the after collision activity. Okay. Now, there were two kinds of collisions. Remember, we have the elastic and we have the inelastic. Now, for elastic collisions, the conservation of momentum is applied to the activity, which means that we can apply the law of conservation of momentum, and regardless of what kind of collision is that, momentum is always conserved for any collisions, meaning elastic or inelastic. But if the collision is elastic, then aside from being conserved for the momentum, it is the energy also is conserved, which means that the two uh, laws can be applied to elastic. But for inelastic collision, we cannot apply the conservation of energy. We can only use the conservation of linear momentum. Why? Because for inelastic collision, the final energy is always greater than the total initial energy must be greater than compared to the total final energy. Okay, why? Because there was outside force that interferes the motion, so it can be a form of friction, no? And it will disappear to the activity. So meaning there must be a loss of energy. Okay, so in this video, let us perform an experiment on the collision. So all you need to do is to decide whether it is a collision or it is elastic or inelastic. Now, we will gather data from this collision because remember that the smart card is a wireless device of collecting data. So meaning all activity, velocities can be measured on the capstone software. So this is the capstone software. So we can provide the velocity initial. So that's before collision, velocity will be recorded. Then after collision, when it returns to its position, then the final velocities can be recorded or will be recorded to the software. Now from there, we can now provide the computations. Okay, so you have to follow the format that we use in our previous experiment. No? Same format. The difference is the table. So we have the data and result table later we will provide it. Okay. Now before that, the card will move. Blue will move initially in a positive direction. So we will assume that this direction is positive, while our red will move towards the negative initially. But after the collision, since the velocity was reversed, then blue becomes negative and red becomes positive. And we can witness that because we have the graph. So if the motion of the particle is positive, then it should be above. No? So for example, this is an example of the motion. So we have here the blue, which is positive. Then, meaning this will be the initial velocity of the particle, the blue card initially. So you have to take the average of this, and this is also the initial velocity of the red card, that is negative. So you can verify that using the table. So for because this is our time, okay, the first row is our time, and the second row, this is the velocity of blue, and we have here the velocity of red. So all you need to do is to look for the table. So start here, but this is increasing velocity, so more or less it starts here. So you have to take the average velocity of this, take the average velocity of that, and that will be the initial velocity of blue, okay, and that is positive. Now in opposite, you can take the average of this, you can use the same, okay, the same number of cells, then take the average of that, and that is the initial velocity of red. Remember, that's negative. Okay, so therefore, again, negative means because red travels in opposite direction of the positive x. Okay, then if we continue in the table, we can observe that the positive direction of blue after collision changes its velocity. No? So uh, find we will not start at this point because this is during collision. So more or less the after collision starts from negative 3.367. Then okay, then you have to take the average velocity at that point. So take the average of that. That is the final velocity of blue. Okay, and this will be the final velocity of red, and that's now positive because that is after collision. So you can verify this in the curve. No. Again, this is the velocity initial of the blue, and that is this is the velocity initial of red. Then this is more or less the collision time occurs at this point. So therefore, after collision, the blue reverse its direction. It will now become positive. So you have to take the average of this. That means almost the same velocity. Then that's it. Okay. So all you need to do in the capstone, we have to gather the velocities, the initial and final velocities of each card. Okay. So. Okay, so this will be our table, no? So the upper, we have the spreadsheet, no, for our data and results. So we have here the first column, the trials. So we have 1, 2, 3, 4, 5. This, it can be more than 5. Then the second row, this is the added or second column, added load to the red. So again, as I've said, we will maintain the mass of blue, which is 0.24 or 240 grams, and we will vary the red. So in order to have, we will vary the change in its mass, no? The difference in its mass. So we have here, for example, we will start at 100. So suppose I have the 100 grams added to 200, this will becomes 350. So this one be recorded as 100, then the final mass of red will becomes, because the red is 250, okay, grams added by 100, so you have to put here what, this must be 300, this must be 350 grams or 0.35 kilogram. Remember that we'll be using SI, so convert that here automatically. Okay, so we have the total mass of the blue will be 0.24 kilograms. Then from the capstone, you have to take the reading, the initial velocity, pick up the initial velocity of blue, and we have the final velocity of blue, then initial velocity of red, and the final velocity of red. That's it. After that, we have now the analysis, momentum analysis. So this columns here, we have the color code. So first is you have to find the initial momentum of the blue card. So remember, momentum is the product of the mass of the card, total mass multiplied by the velocity. So it should be this blue, okay? Total mass of the blue multiplied by initial velocity, and the answer should be the initial momentum. And after that, we have also to find the initial momentum of the red card. Okay, so it should be the total mass, take note, added plus the 250 of the card. So in this example, I have to put here 0.35 or 350 grams. then multiply it with the initial velocity, then it should be the initial momentum of the card, red card. Then for the blue card, this should be the final momentum. So the final momentum is equal to the mass times the final velocity. Then put the record here. Take note the unit should be kilogram meter per seconds. And the final red, so do it the same mass, but you have to multiply it with the final velocity. Okay? You have to consider the sign. Remember, the sign is negative if it is in opposite direction. So positive or in this direction. Okay? So, then after that, you have to find the total initial. So, the total initial must be what? The total initial momentum, it should be the initial momentum of the blue added algebraically, okay, by the total momentum of, or the initial momentum of the red card. So you have to combine it algebraically. Remember that one is positive, the other is negative. So the total must be the algebraic sum. Okay, then for the final momentum, you have to add algebraically again the final velocities of red and blue. Okay, and after that, we will find the difference. Find the difference between the two collisions, the initial and final. So, difference means, okay, to calculate the percent difference, it is actually the percent difference away from the initial. Meaning, we will do this way. The final momentum, or the initial momentum, minus the final momentum divided by the initial momentum. And that will be the percent difference. Again, for the percent difference, all you need to do is to take the difference between the final minus initial, meaning it should be the final initial momentum subtracted by, the total initial momentum subtracted by the total final momentum divided by the total initial momentum. Then multiply it with 100%, and that will be the difference. This is just like the same on the percent error, but in this case we are looking for the percentage of the final momentum away from the initial. So actually our initial will be our reference. So the total final momentum, the total initial momentum subtracted by the total final momentum divided by the total initial momentum all over, okay, then multiplied by 100%, and that will be the percent difference of the collision. Okay, so we are done in the momentum analysis. Then let's proceed to the energy analysis. So we have here the initial velocity of the card, initial energy of the card blue. Remember that energy in this case is only kinetic energy, because there's no potential for the reason that they are moving in the same level. So when we say energy, it is the kinetic energy. So the kinetic energy of the blue card will be, remember the formula is 1/2 mv squared. So we have the mass of the blue multiplied by initial velocity of the blue, and that will be the velocity squared. Okay, 1/2 times the mass times the velocity squared is the initial velocity or initial energy of the blue card. And do it the same on the red card. So it should be the mass of the moving red card. Total mass is 1/2 the mass times the velocity of the red card will be the energy. And take note, the unit should be in joules in SI. Now do it the same in the final energy for the blue and the final energy of the red card, 1/2 mv squared. Okay, with that, we can calculate the total energy. So it should be initial and final. So add the initial velocity of blue to the initial velocity of red. Now take note that all of them are positive, no? Because even if the velocity is negative, when you square it, it will become positive. So the energies are all positive. So you can combine it, no, without negative, without the sign, because all of them are positive. Unlike in momentum, no, because momentum, we have the negative momentum and we have positive momentum. But in the energy, since we compute it using 1/2 mv square and a velocity square, so regardless of, even if you have a negative velocities, when you square it, it will become positive. So energy are always positive. That's kinetic energy. Okay, then do it again. So we have now the total initial energy, and we have the total final energy. Then the same, take the percent difference. So it should be the measurement of the final energy away from initial. So when we take the percent difference, it should be the total initial energy subtracted by the total final energy. So all of them divided by the total initial energy. Okay, so the energy initial will be our reference. Then all of them multiplied by 100% to come up with a percentage result. So the same as in the momentum. So meaning, in that reason, in that way, or process, we can observe, no, the percent difference. So if the percent difference is less than 10, meaning it is elastic collision. Kindly change this should be elastic, no? Elastic collision or inelastic. So after that, you have to decide whether elastic or inelastic. But in this case, your answer here will be based on the percentage or the percent difference for energy. Because remember, elastic and inelastic, the momentum is always conserved. So meaning, in this case, we can always notice that the percent difference must be less than 10% always. But in this case, it can be less than or greater than. Now our system now is we are using the magnet, so they can easily reverse its direction because of that magnet. But later on, we'll remove this and change this with the rubber, and let's see what happened next. Okay, so all you need to do again is to comply this requirement. Then meaning supply the data, then calculate, and this will serve as our data and result. So use the same format in our previous experiment, except the data and result. So we are providing again the title, the right title, the materials, apparatus needed. Then we have the decide your own objective, and so on. Then follow the same. Now in the last column here, so it should be remarks, no? So you have to the result. So why is it that it is elastic, or why it is inelastic? So give some remarks on the last column of the table. Okay, so let us now perform the experiment. So careful of gathering the data. Okay, so in this, our first trial, we will add 0. So we will not add a load, which means that the blue is again 0.24 kilogram, and this is 0.25 because this is 250 grams. So our first trial is added 0 load to the red card. Okay, so let's click the record, then allow them to collide. That's it. So stop. Sorry. Okay, let's do it again. Okay, again, for the first trial, no added load to the red. So that is trial 1. Then click record, then allow them to collide, then stop. Okay, so this will be your data. Okay, so look at the graph. the graph here, this is the velocity of the cart. So all you need to do is to take the average of this, and that will be the initial velocity of the blue, positive, and this is the initial velocity of the red, positive, negative. And for the final velocity, because the red is changing its direction, this will be now becomes plus. So take the average of this, and the blue becomes negative. So take the average of this. So we gather only the initial and final velocities of the two cards. So in the table, this is the, all you need to do is to, okay, let's go back to the first line. So you can notice that the average now is more or less perfect. No? So we have this, the velocity. So take the average velocity until this point. Okay, that's it. No, because after this we have point 2 decreasing until changing. So you can do it. You can take the average of this. So please record. Take the average of that. That will be the initial velocity of the blue. Okay, the initial velocity of this blue card, positive. Then in opposite, this will be the initial velocity. So take the average of that. The average velocity of the red card. So it can be found in the, again, in the graph. It's below. It's negative. So take the average. That is the initial velocity. Now for the final velocity, okay, so let's move downward. Take note that for the blue here, we have decreasing value, then change it negative. So this will be the ideal value. So take the average of this. That's it. Take the average of that. That will be the final velocity of blue. Then in the opposite side, this will be the final velocity of red. Okay? This is our first trial with no added load. Okay, for the second trial, the added load is 100 gram force. Okay, 100 gram or grams, sorry, added to the red card. So it's now 250 added by 100 becomes 350. But while the blue is 0.24 kilograms, so we will maintain the mass of the blue card. Okay, so then start recording. So click the record button, then release, then stop. Okay, so this stop. This is our data. So again, look at this one. The blue again is positive, and we have the red is negative. Then after collision, this one. So meaning this is ideal data that we can use. Then for the blue, this one. So the table, again, let's start at 0. So go over, no? You can use this until that point. So take the average velocity of that. That will be the initial velocity of blue. Take a record. Okay? Then for the red, negative, opposite, no? Column, we have here the velocities for the red. So take the average of that. Remember, it's negative because it's initial. Now for the final velocities of the two cards. So you can start here. So since, remember, this is the blue, then this is now during collision. Then after that, reverse its direction. So the normal velocity as it travels more or less start here. So take the average of this, and that will be the final velocity of the blue card. So remember, negative. Then opposite, direct opposite to that, take the average of that, and that will be the final velocity of the red card. Okay? So this is our second trial. That's it. Okay, for the third trial, add another 100. So the total added now becomes 200 plus 250 of the red becomes 450 load. Okay, so again we maintain the mass of the blue, which is 0.24, and this is now 0.45 because this is 450 grams. Okay, so let's click the record button, then click, then allow them to collide. That's it. Okay, so that's the data. So for, again, have the same this one. So for the initial velocity, take the average from here up to the positive maintain velocities. So take the average of that, no, of the velocity for the blue initial velocity. Then in the opposite, we have here the negative velocities for the initial velocity of red. Okay, then in the final velocity, scroll, okay, it start here, more or less. So take the average of this. This will be our final velocity of the blue cart. Take the average of that. Okay. Then in the opposite, same column, number of cells. Oh no, same rows. So in the last column, that will be the final velocity of the red, and take the average of that. So this is our third trial. So the third trial. That's it. Okay, for the fourth trial, add another 100. So this will now becomes 300 load, no, grams added to 250 cart. So 300 plus 250 is 550, and this is our fourth trial. Okay, so let's start. Click the record button, then allow to collide, then stop. Okay, stop. Okay, let's do it again. Because it will. So take two. Click the record. Click the record. Then allow to collide. Then click. That's it. So let's expand the data. That's it. Very nice. So all you need to do, again, from the table, use this one. Then, okay, you can use this 0.46. We'll start at 0.46, then move until that cell. So take the average, from 0.46 to 0.142, and that's the initial velocity of blue. Then respectively in the direct opposite, and this will be our initial velocity of red. So again, take the average for the initial. Then for the final velocities, you can start here for the blue, then have the average reading of that. Take the average. The final velocity of blue is negative. Then respectively our final velocity for red. Okay, so this will be our fourth trial. Okay, for the fifth trial, and this will be our final trial. So we'll remove the magnet on the bumper of the cart, the two carts. Then we will replace it with another material, but still this is rubber. And let's see what happens, no? And what the difference. This is our last trial. Okay. Then we will add, the added load is 300 plus 100. So this is now 400. 100, because this is 50, 2 pieces of 50, so 100, 200, 300, 400. So 400 was added to the red card. Okay. Then this is our last or the final trial. Trial number 5. Okay, so let's start recording. Click the record, then allow them to live, then that's it. Okay, so look at the result, and this is our data. Okay, so all you need to do, same procedure. Okay, you have to take the average up to that only for the blue. Okay, so that will be our initial velocity of blue, and the initial velocity of red, you can use the same, no? You can use the same. That's for the red. And for the final velocity of blue, use this one. Take the average of this. That is the final velocity of blue. And the final velocity of red is respectively, that's it. Okay, so that's all for our experiment, no? So be sure to gather it correctly.